Hello all. I'm going to do two really quick videos today just to go over some really basic statistics, and so we can talk a little bit about error, both random noise and bias error. And most of this is probably completely reviewed. You've seen it in biology or physics or chemistry or something like that you took in high school, but I just wanted to walk through it to refresh your memory so that you remember a few basic things. So what we're interested in is finding out whether something in fact is a real effect or whether it's just noise. Now it turns out that all experiments have noise of some kind or another. There's some sort of experimental error built into them. And this is because, for two reasons. Number one is that our measurement instruments are not infinitely precise. That we cannot, if we try very hard, you can take like a ruler and measure a board and figure out how long it is. But there's some slop in that because the tape measure is a little bent and the lines on the tape measure aren't perfect, narrow and everything else. And you could do this with more and more. You could get out a laser micrometer, for example, and measure it much more carefully, and so on and so forth. But at some point, you're always going to have a little bit of error, and it's always going to be, it's maybe 3 feet long or maybe 3.01 feet long or something like that. Just depends on how carefully you measure it. And we can do very, very careful measurements indeed. In fact, the recent gravity wave detection at LIGO was the equivalent of measuring the distance from the Earth to the Sun within the diameter of a proton. So we're very good at this, but we're still not perfect. So there's always a little bit of slop and error, and even in physical measurements. And when we get into discussions of trying to deal with humans, it turns out there's huge amounts. So the question becomes, how do we determine whether something we're looking for is in fact just part of this random noise or whether it's actually interesting or not? So let's do a sample problem for this. And one of the sample problems is real simple. Let's just ask ourselves, we have a coin, we're going to flip it, and is this coin fair? In other words, are we likely to have 50% heads and 50% tails? So let's go ahead and flip the coin once. And if we flip the coin once, we get a head. Nobody would think anything unusual of that. There's a 50-50 chance. Okay, so that's not a particularly unusual response. How about if we get heads, heads? Well, we can compute the probability of that really easily. The first time you roll a head, you have a 1/2 chance. And the second time you roll or flip the coin, you get 50% chance. So 1/2 times 1/2. And 1 in every 4 times you flip a coin twice, you'll get 2 heads. That's not unusual. So neither of these we could tell, for example. But let's, for example, ask ourselves if we got the following response: head, 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 head. Now you might be starting to get a little bit suspicious. 10 heads in a row seems really strange. But it turns out it's really actually not. If you think about it, that's just 1/2 times 1/2 times 1/2 10 times. So it's really 1/2 to the 10th, or about 1/1024. Unusual, certainly, but certainly within the realm of probability. You couldn't completely rule something out at this point. How about if you got 100 heads in a row? At that point, you are really beginning to wonder if there's something wrong with your coin. You didn't get it from a normal store, you got it from a magician shop or something like that. Again, we can look at this. This would be, probability would be 1/2 to the 100, which is a little bit larger than 2 to the 10. In fact, it is 1, 2, 6, 7, 6, 5, 6, 0, 0, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 1 all over that number. That's rather more than the number of particles in the universe, so at this point the coin is probably almost certainly wrong. But somewhere in between here, though, for example, if you flipped a coin 100 times and you got 50 heads and 50 tails, you wouldn't think anything of it. If you got 51/49, well, that seems pretty reasonable. How about if you got 55/45? Is that enough to make you say, wait a minute, this coin is false or something like that? How about 60/40? You can keep doing this and asking yourself, at what point do you start wondering whether the coin has a problem or not? So one way to do this, of course, and the way to eliminate errors in experiments, is you typically do the experiment multiple times. And that's easy enough. So what we're going to do is let's take a look at a series of experiments where I flipped a coin 100 times, and then I repeated that experiment 10,000 times. Obviously, I didn't do this for real. I wrote a computer program to do it. But here's the data that you're going to get out. So here's our data on 100 coin flips. We've repeated it 10,000 times, and we counted the number of times that the coin appeared that number of flips. So for example, in the middle, as you might expect, the highest peak is at the 50 mark. So 50 heads, 50 tails shows up most frequently. And out of the 10,000 flips, roughly about 400 of them or so showed up that way. Here's 5149, 5248, 5347. All of those are pretty reasonable. I mean, they're still showing up lots of times, like over 350 times out of 10,000. So they're not that much unusual, much less probable than having 50-50 chance. How about getting down to here? That's 58, or maybe, for example, I said 60-40. There's our 60-40 point. That still shows up 50 times. That's not unusual. How about if we said 65-35? There's 65, and there is actually, whoops, actually is a little tick up there. In fact, actually, if you look at the actual numbers, there's a tick there, and in fact, there's even a tick out at 70, and there's one over here at 32. So you can see that you can get quite wild results. This is a perfectly fair coin, but you can still have times when, for example, you flipped 70 heads and 30 tails. No, that was because you flipped it 10,000 times. Now, but we can ask ourselves, what are the probabilities that, in fact, the coin is, in fact, not fair? And that becomes fairly obvious. If it's over here, it's probably fair. As you move farther and farther out, it becomes less and less likely. And we're going to talk in the second half of this about a curve known as the normal distribution, which takes into account the shape of this curve quite nicely.